Hello, my name is Katie Kilpatrick, and this is the journal assignment for week 4. At rest, the respiratory, cardiovascular, and neuromuscular systems act differently than they do during and post-exercise. I used my living room to document all the requirements for this journal entry. While resting for 5 minutes, I felt a little chilly as it was a colder early spring morning here in Nebraska. The first data that I collected was my resting heart rate. To do that, I counted my pulse for 10 seconds, which happened to be 10. So at rest, when my pulse rate of 10 was converted by multiplying that number by 6, my resting heart rate was 60 beats per minute. My body was in no way fatigued or sore. My muscles were not tense, and I felt calm. I had no trouble breathing, but noticed that my breath was slowing down as the 5 minutes went on, and my inspiration and expiration became fuller and deeper. Overall, my resting state felt mellow and calm. To see changes to this resting state, we were asked to perform 6 minutes of physical activity, which consisted of jogging in place for 3 minutes and performing push-ups for 3 minutes, or to a point of fatigue. Once the exercises were completed, I immediately calculated the same data that I did while at rest. My pulse count was 23, which when converted in the same manner as before, I had a heart rate of 138 beats per minute. At the start of exercising, which I started with the jogging, I instantly felt a strong need to breathe more air at a faster rate. The intensity of muscular contractions also increased. I noticed that my biceps and chest were tense and sore. When I was at rest, I did not feel any of these muscular effects. During the exercises, I found it easy to hear and feel my heart rate increase. My body temperature also seemed to change as well. I no longer felt chilly or cold, as my body now was feeling a little warmer. I also noticed that my body, especially my head and my hands, had just started to sweat during the exercise. Overall, during exercise, I felt more exhausted than while at rest. There are several reasons to explain the changes I experienced post and during exercise. According to Ketch, McArdle, and Ketch, when exercise stops, ventilation decreases rapidly to a point of about 40% of the final exercise value, and then slowly returns to a resting state. We can see this in the heart rate calculations. The reason that the respiration rate, or heartbeats per minute, was higher than at rest is because it was 40% of what I was breathing during the exercise. We know consistent exercise is good for us, but why is it good for us? Well, if we look at the chronic or long-term adaptations that happen in the cardiovascular, neuromuscular, and respiratory systems, we can gain a little more insight into the answer to that question. One of the chronic adaptations made by the cardiovascular system is that the heart and lungs become more efficient at delivering oxygenated blood to the working muscles. There's also an increase in efficiency of removing waste products such as carbon dioxide and lactic acid from the body. Chronic adaptations that occur in the muscular system are that the muscles can perform greater amounts of work by extracting oxygen from the blood more efficiently, and there is also an increased capacity within the muscle to produce and store energy. In the respiratory system, the chronic adaptations we see are improved lung mechanics allowing more air to ventilate. The lungs also become more efficient at delivering oxygen to the alveolar capillaries and removing carbon dioxide from the body. And that's what I have discovered in my personal experience and just through our coursework with exercise and these body systems. Thank you.